Welcome to Prince Maths Clinic, the e-learning solution at your pace and time.
Hi, and welcome once again to class. This is Prince Maths Clinic, and if you have not subscribed to this channel, kindly do so. Share this video to your friends and loved ones, and more importantly, click on the notification bell so that you can be the first to get videos from this channel. Having said that, this is the continuation of the logarithm class that we started in the previous edition. And in today's class, we shall be looking at the other laws in logarithm. As a way of revision, we looked at two laws in the previous class. We looked at the law of addition, that as long as the bases are the same, you multiply the first log with the second log. And in the second law, which is the law of subtraction, we said that as long as the bases are the same, you divide the first log with the second log. Having said that, let's go into today's work to look at the other laws of logarithm. And the first law I have here is that when a log is carrying a power, you use that power to multiply the log. Right? You have a case like this. Let's say you have log 3 to the power of 2 base 2. All you need to do is to move this 2 here. So this becomes 2 log 3 base 2. That is all we need to do, as long as this is carrying a what? The log is carrying a power of 2. So let's look at other interesting examples to buttress this point. If I have log 100 in base 10, I can express this as 100 is 10 to the power of 2. Then the base is what? Is 10. Then you move this 2 here based on what this law said, right? So this becomes 2 log 10 base 10. And when a log and a base are the same, it cancels out. So you are left with what? 2, because 2 times 1 is 2. Let's look at another question. If I have log 343 base 7, right? Take this as the second question. This can be further broken down like this. 343 is the same as 7 to the power of 3, because 7 times 7 is 49, and 49 times 7 is 343. Then the base is 7. Then bring this here again. This now becomes what? 3 log 7 base 7. And in this case, the log and the base are the same. You cancel out. So 3 times 1 gives us what? 3. Now, let's look at a third question to buttress our point. Wow, here you have log 25 in base 5. So what do? Write out your question. 25 is the same as 5 raised to the power of 2. So this becomes 5 to the power of 2, then the base is 5. Then move this here again. This becomes what? 2 log 5 base of what? Of 5. Now let me take one more example. What if I have a situation like this? Interesting. Now log 25 base 5, right, is here. Then it's being multiplied by half, which is 1/2. Now the goal is to move this back as a power. So therefore, have log of 25 in base 5. If this goes back to the power, this becomes log of 25 base 5 then this 25 is carrying the power of half. Now, because we are handling the laws of logarithm, I'm going to leave my answer here, although this is not my final answer, because 25 to the power of half means square root of 25, which is what is going to give us 5. And when a log and a base are the same, it cancels out to become 1. But for the sake of just showing you how the laws operate, I'm going to leave my result here. Good. So now let's look at the second law, that is number 4. When a log and a base are the same, it becomes 1. No matter what the base is, and no matter what the log is, as long as the log and the base are equal, it becomes 1. And that is easy to prove, right? Because if you do change it back to indices, this becomes b to the power of 1, which is same as b. Good. So let's look at 1 or 2 examples there. I'm looking at these examples. The log and the base are the same. It turns to 1. The log and the base are the same. Therefore, this becomes 1. The log and the base are the same. This becomes what? 1. Why is it so? It is so because if you power the base with what you have here, it still gives you this. 3 to the power of 1 still gives you 3. 7 to the power of 1, this still gives you 7. Now, a note of warning. As long as the log is not 1, right? This rule holds. Once the log is 1, there is another law that works for it, and that takes us to law number 5. That is, when you have log 1 to any base, the result will always give you 0. Logarithm of 1 to any base will always give you 0. Now let's look at some examples. Now look at it. You have log 1 base 10. You don't need to stress yourself. Just as long as the log is 1, just say it is equal to what? 0. Because if you do 10 to the power of 0, any number to the power of 0 still gives you what? 1. It's as simple as that. Or another method you can use to do this, you can say let log 1 base 10 equals to an unknown, call that unknown x, right? Therefore, you can now say 10 to the power of x is equal to what? 1, right? Is it not so? Good. Then the other thing you can do here is to what? Is to imagine what will you, because the basis must be the same, what will you do to make this place 1 if the base must be 10? The only thing you can do is to say 10 to the power of x can only be equal to 10 to the power of 0, because anything to the power of 0 gives you 1. And now you can see that the bases are the same, therefore the powers are equal. Therefore, if x is the power, that means that x is what? Is 0, which you have here. But I think this is quite shorter. Just know that it is 0. Just assign 0, right? Good. Then the second question is the same as well. The base here is what? 100 becomes 0. If the base here is what? 100, right? So this means that this place is what? 100. So the only way this could work out is if this is also 100 to the power of 0, right? Therefore, x becomes 0. Then lastly, the intriguing one here is log 1 to base 1. When you have log 1 to base 1, it is still 0. Why? Because if you say 1 to the power of 0, you will still obtain 1. Finally, in today's class, we shall be looking at how we can change the base of a particular logarithm. Usually, we do this when we are not comfortable with the base that is being given to us, or the log that is being given to us. So we change it to a very favorable or very conducive or very look for a better word to replace all I've said. You look for a base that you can easily work with. Now, let's take this particular question. We want to evaluate log 32 in the base of 0.25. Solution. We know that 0.25 is the same as 25 over 100. How would you arrive at 25 over 100? Remove the decimal part, 2 places, just take it off, 1, 2. We moved it twice, so write your 25, then you put your divide. We moved it twice, so just put a 1 and 2 zeros because we moved it twice. So 25 can go in 100 4 times. So this is the same thing as saying 1 over 4. That's the base. Then this is the same as what? 32. Good. 32 is of course there. Then how else can we write 1 over 4? Remember, 1 over 4 is the same as 1 over 2 to the power of 2. And when you have a division like this, from what you know in indices, right, this division becomes a negative power, then this 2 comes like this. So this can be written as 2 to the power of negative 2, right? Good. But I will not even bother ourselves with this, right? I'm only explaining this to you. But I can write this as well as 4 to the power of negative 1. Remember, this division comes to negative, right, in the power. Then, because it is just 1 over 4, that's why I have it up. Because this is the same as 4 raised to the power 1. 1 over 4 is the same as 1 over 4 to the power of 1. Because 4 to the power of 1 still gives us 4, right? Good. So you can express it like this. This division here is the reason for this negative power. Then this 1 is what you have here. Good. So I want to express it like that. 4 to the power of negative 1. Then the log is 32. Good. Now, I can see that I don't like the base. I want to change the base. So what do? I want to change it to a comfortable base that will suit my operation. I want to take the base to base 2. Like I said, I want to take the base in base 2. This is how you do it using this law. You take the first one, you put the convenient base you want, which is C in this instance, then over log of B, then the same base that you choose in the numerator, that's what you use in the denominator. So here I've chosen to use 2. Therefore, this becomes log, you can say, therefore, log 32 base of 4 raised to the power negative 1 equals to log 32 base of 2 divided by log of, this is, remember, this is 4 raised to the power negative 1. The base is still what? 2. Remember, this is a power. Now, I know that 32 is the same as 2 to the power of 5. That is 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. So this becomes log 2 to the power of 5. This is 32. Then the base is still 2 over this. You apply the law 3 here. the power, we have to multiply the log. This becomes -1 log. Now, this 4 is left here, and 4 can be expressed as what? 2 to the power of 2. This is still the same as 4. Then the base, of course, is 2. You can see. Then, in both cases now, you can now take the power, multiply the log. So this becomes 5 log 2 base 2 over, this is still 2, but 2 times -1 gives us -2. Then you have log 2 base 2. In this instance, log 2 base 2 cancels out, so we are left with -5 over 2, or we can call it -2 whole number 1 over 2, or we can call it -2.5. This brings us to the end of today's class. I hope the video was helpful. Kindly like the video, share it with your friends, and ensure that you click on the notification bell so that you can get more of such interesting and exciting videos. Till we meet again, bye for now.